JSA. A JSA helps you find hazards and eliminate or minimize them before the job is performed, and before they have a chance to cause an accident or a fatality. In some cases, JSAs can also be conducted throughout the course of a project. A job safety analysis is a process to improve safety. It's a way of looking at a job to see what the hazards are and how to deal with them.
A JSA involves 3 steps: breaking the job into steps, identifying existing and potential hazards, and developing a plan to eliminate or control hazards. This helps prevent future accidents. An analysis is conducted using the JSA Worksheet. The worksheet is a step-by-step method for recording the job steps, hazards, and suggestions for improvements. Completed JSA worksheets are an invaluable part of an effective safety program. They can be used to train or update employees, to create or improve standard operating procedures, and to record safety information for infrequently performed jobs. They can also serve as a guide for employee performance reviews, training, and accident investigations.
This video will take you through a sample JSA step by step. You'll learn how to set priorities for doing JSAs and how to conduct an analysis using a JSA worksheet. To conduct a job safety analysis, you need a JSA worksheet. This worksheet is divided into 3 columns.
The first is for listing the basic steps necessary to perform the job from start to finish. The second column is for identifying existing and potential hazards associated with each job step. And the third is for recording suggestions for eliminating or controlling each hazard. Complete the worksheet 1 column at a time. For example, all the basic job steps should be listed before writing down any hazards. And all hazards should be identified before listing any recommendations. Concentrating on 1 column at a time helps ensure that the information in each column is accurate and complete.
To improve overall safety at your work site, you'll want to do a JSA for every job on the site. Since you can't do it all at once, it's important to prioritize which jobs you want to analyze first.
It's a good idea to look at jobs with poor accident histories first. You can find this information by looking at injury illness records and workers' compensation claims. Watch for jobs with frequent accidents, a history of disabling injuries, or the potential to cause severe injuries. Jobs that have undergone changes in procedure, equipment, or materials are also good candidates for a JSA, as are jobs that might have been affected by new OSHA regulations or standards. And it's important to analyze new jobs with little or no history. Ideally, a JSA should be performed before anyone is assigned to do the work.
Once you have the JSA worksheet and a job selected, you're ready to begin the job safety analysis. The first step is to break down the job process.
Select an employee to observe. The employee should be capable, experienced, and willing to share ideas. Make sure you explain what you are doing if this person has never participated in a job safety analysis before. Watch the employee work and record each step on the JSA worksheet. It's important to focus on what's being done, not how it's being done. Use action words and a moderate amount of detail. Enough to cover all the basics, but not so much that the information is overwhelming. One suggestion is to ask yourself these questions. What step starts the job? What's the next basic step? And so on. It's especially important to record any steps that deviate from the regular procedure, as these may be the cause of accidents. Another good idea is to videotape the job. That way you can use pause and rewind to pinpoint details of the job, and you'll have a reference for further study.
Let's do a sample JSA on a job similar to the one that led to Doug's accident. Remember that JSAs help prevent accidents. Look carefully to see if Doug's could have been prevented. First, we'll go over the steps of his job. grinding a bad weld in a confined space. The steps are:
checking to make sure that appropriate confined space entry procedures have been followed, climbing into the pipe, grinding the weld using a power grinder, and climbing out of the pipe.
Once you have the job steps recorded, you can move on to step 2, listing existing and potential hazards associated with each step of the job. Watch the employee again, keeping an eye out for hazards caused by both the job procedure and the job's environment. Ask what is being done and why it's being done in this way. Remember, employees are the experts on their jobs. Often talking with them and asking questions gives you invaluable insight into problems with the job. Write down any obvious hazards and look for potential problems. Once you know what the hazards are, you can determine key factors related to safety.
Let's look at the grinding job again. The most obvious hazard is the sparks from grinding. With adequate personal protective equipment, such as a face shield, the sparks aren't a problem. But a change to the environment is a potential hazard. Let's look for other hazards in the job. These may include placing the head inside the space while testing the air, getting trapped while entering, cuts from rough edges, poor visibility, grit and metal dust in the air while grinding, low oxygen levels inside the pipe, hazardous fumes, and difficulties in crawling backwards out of the pipe due to restricted movements.
Now that we've pinpointed what the hazards are, the next step is to develop controls for each hazard identified. This can be done in one of two ways: by finding a new way to do the job, or by selecting specific controls for each hazard. If you decide to find a new way to do the job, first determine if the job can be eliminated. Some jobs, such as an employee lifting or carrying materials, can be replaced by machinery like a forklift. This eliminates hazards associated with poor lifting techniques and too heavy loads.
Or look to see if the frequency of the job can be reduced. Planning ahead can reduce the number of times materials or equipment has to be moved. Another idea is changing the physical conditions that create the hazard. For example, if you're working in a confined space with hazardous fumes or metal dust, adding fans for ventilation will significantly reduce the amount of hazards in the air. Or make changes to the job procedure. Using a sampling pump with a hose to test the air in confined spaces eliminates the need for an employee to enter the space for testing.
Let's move on to the other option, selecting specific controls for each hazard. See if the job process can be eliminated or modified through engineering controls. For example, using a creeper or lifeline to assist employees going into confined spaces can eliminate the physical problems with restricted spaces.
Suggest a different tool or piece of equipment. Warning guards and barriers can also reduce hazards. Signs and barriers around a demolition site protect both the workers and the public from hazards such as falling materials. And sites should always post warning signs, such as this confined space sign. Try using administrative controls to reduce exposure levels to the hazards. One suggestion is using job rotation. This helps minimize exposure by shortening the amount of time that one worker is exposed to a hazard. Another administrative control is assigning an attendant to all permit-required confined space work. The attendant stays in constant contact with the workers inside the space and watches for signs of overexposure. It's essential to provide appropriate personal protective equipment. Proper clothing and gloves protect skin from hazardous materials. A face shield protects the worker from sparks. An airline respirator might have been appropriate in Doug's situation. It would have supplied him with breathing air while maintaining safe atmosphere levels. Safety education and training is another control and one of the most effective ways to protect employees from hazards. A brainstorming session with workers, supervisors, or the company safety director is also a good way to discover and explore solutions. Be creative and work with ideas and suggestions.
A job safety analysis is a vital part of uncovering and eliminating or minimizing hazards from a construction job. A JSA involves
breaking the job into steps, identifying the hazards, and developing a plan to eliminate or minimize these hazards.
Remember, every construction site is unique, so it's likely that you will come across some jobs that don't have a specific written JSA. Grinding a bad weld in a pipe is one example of a job that's only occasionally done. In cases like this, it's a good idea to look at several JSAs for similar jobs, then take this information, combine it with your own knowledge, and apply it to the situation. A construction site is full of hazards, but these can be dramatically reduced by performing frequent and effective JSAs. A job safety analysis allows you to play a vital role in improving the safety and well-being of everyone at the job site, including you.
Well, we're all on the team, and part of our responsibility is to keep everybody on the team safe. I like the fact that the job safety analysis process gets everybody involved in the safety process. Accidents, they affect us all.
I wish I'd have known about JSAs before the accident. I firmly believe that it would have kept Doug safe and alive.